We're going to take a look at two examples where we're being asked to express the meaning of a function using functional notation. So in this first example, we're given P of t, and we're told that P of t represents the profit I expect my business to earn. So I'm just going to rewrite this. Okay, P of t is the notation that means expected profit. Okay, so for example, if I have P of t equals 20, that means that my expected profit after some year t is going to be 20. Okay? If I have P of t equals 100, that means that after some time t, my expected profit is going to be 100. And assuming that it's in dollars, we can say $20, $100, etc. Okay? In this particular problem, we're asked to use the functional notation. So functional notation is when you write something like P of t, or when you write like f of x, or you write like h of n. These are all different functional notations. So we're asked to use functional notation to express what the expected profit is after 2 years and 6 months. Okay? All right, so here it's important for us to not only know what P of t stands for, but we need to make sure we understand what t stands for. So t stands for the years after opening. Okay? All right, so that must mean that if t is 0, we haven't opened the business yet. If t is 1, that means 1 year after opening. If t is 2, that means 2 years after opening. If t is 3, that means 3 years after opening, etc. Okay? All right, so going back to this phrase, we are trying to write the notation to express the expected profit after 2 years and 6 months. I'm going to write that phrase down. Okay? Oops. So I want to know, what is the expected profit after 2 years and 6 months? Okay, that's a mouthful. That's a lot of words, and it's a pretty long phrase. So is there a shorter way of writing this phrase so it has the same exact meaning, right, but less words? And the answer is yes, of course there's a way for us to rewrite this, because mathematicians were lazy. If I could write a notation that means this entire phrase, why not use the shorthand or their notation? All right, so to write this using functional notation, we use the notation that we defined in the original problem. So I know that P of t, right, represents the expected profit, and I don't actually know what that number is, but that's okay. All right, that's not what we're asked to find. We're just asked to write the notation. We're not asked to actually find the profit. All right, okay, so going back. So P of t represents the expected profit when t is 2 years and 6 months. So I know that if I write 2 here, that means 2 years. But how do I represent the 6 months, right? Because I have to represent 6 months in terms of years, because that's how we define t. T is defined in years, right? So you just think about it. Well, how many months are there in a year? There are 12 months in a year. So if I had 12 months, that would be equivalent to when t is 1, right? But 6 months, that's not quite a year yet. In fact, it's half a year. So in terms of t, that would be a half. All right, so if I want to express 2 years and 6 months, this must be the notation P of 2.5. And that's it. So P of 2.5 represents the expected profit after 2 years and 6 months. Okay, let's take a look at another example. In this problem, we're given a function. We call that function c of p, s, h, where c stands for the cost of buying p bags of potato chips, s cans of sodas, and 8 hot dogs. So I want to use functional notation to express the cost of buying 2 bags of potato chips, 3 cans of sodas, and 5 hot dogs. So that's just The notation is just simply c of 2, comma, 3, comma, 5. All right. Now I want to point out to you that this function has three input values. So functions, they sometimes can have just one input value, but sometimes they can have two or more. Okay. But when you have a function that has two or more input values, right? When you write the notation, the order in which you write the input values is really important. Because if I write c of, let's say, 3, comma, 2, comma, 5, this now has a completely different meaning, right? This notation means the cost of buying, right, 3 bags of potato chips and 2 cans of soda and 5 hot dogs. Okay, which is very different from buying 2 bags of potatoes and 3 cans of soda. Okay, again, if I were to rewrite this in a different order, 5, comma, 2, comma, 3, this notation now has a different meaning, right? And that meaning depends on, right, the notation. So this order is really, really important, okay? Because here, once I change the order, now I'm saying that this represents the cost, right, of buying 5 bags of potato chips, okay, 2 cans of soda, and 3 bags of hot dogs, or 3 hot dogs. Okay, so again, just pointing out that the notation is important, how the notation is defined for the function is important, and it's important because it tells us how to read the notation and then what it means.